So it's not that the Concorde didn't work. It worked fantastic. It was very, very expensive. And so the number of people who wanted to do a transatlantic flight at that price was just outrageous. So that's the only problem. And I think the idea that Musk had, the one that buys this, is a worldwide, global, high-speed internet. That's the thing that pays for all of those things. You launch one of these BFRs, 150 tons. You put up an entire constellation of these satellites in 2 launches, and you now own the worldwide cellular internet high market. Like, done.
Yeah.
So that's how you pay for it. And then what? Then whatever's next, right? You launch the worldwide weather satellite and the worldwide Earth observation network. Like, there's a ton of things that you can do that will pay for this. I don't see it being that suborbital flights are the suborbital flights are going to weigh you pay for this. I don't see that. So it was very weird to me. So those parts that I really loved,
advertise it.
Yeah, there were parts that I really loved, and then parts that were really weird to me. So anyway, hey everybody, welcome to a live episode of Astronomy Cast. And yeah, I was ranting, and I just switched to live, and here we are.
And welcome to the inside of Fraser's head.
So before we go on, I gotta show you this. So
this is amazing.
I'm not sure if anyone saw this, but we were Wednesday night. My phone went bleep bloop and said there's a geostorm overhead, and so we went out. I took the family. We went out to a nearby place to see the sky, and we saw the most insane aurora activity I have ever seen. It was unbelievable. It sort of started out as this kind of like a rainbow across to the north, and we were like, well, this is the best we can get for how south we live. And then over the course of the next hour or so, it just went and it was this enormous aurora activity with ribbons, and it was unbelievable. So I'm going to show you. We took a time lapse, and I'll show you sort of what we saw. Let me see if I can do this. Okay, so here's where we go. Here's where it started. All right, so check this out. And I'll just do that one more time.
So when I first saw this, I thought you were forwarding someone else's, and then I realized there was no credit, and you would have had a credit line.
Yeah. We took it. I've never. It was, and so I actually have a recording from my. I have a recording from my phone, and you could see the aurora activity in my phone. And me and Carla and Logan were all just like, what? It was crazy. It was unbelievable. So get some kind of aurora announcement. I'm sure this aurora activity would have been visible very far south, probably any part of the United States, probably most of Europe. The folks in Australia, New Zealand probably would have seen this as well. South America. So get some kind of aurora bleep blooper on your phone and go out when the aurora activity is high, and you never know what you're going to be able to see. So that was life-changing. Now every time my phone tells me there's even the slightest risk, I'm out there.
So bleep blooper is your new word for notifications?
Yeah, some kind of gadget that says, hey dummy, there's aurora activity going on. So
I approve.
Yeah. I use an Aurora Alert app called Aurora Alert, and but I mean, there's a bunch.
You're on Android.
Yeah, I'm on Android, so there's a bunch, right? Like Aurora Alert service, you can get one of these things. They exist.
I get it in Twitter, so I get all of my notifications.
Yeah.
All of us.
Right.
There's so many different ways to get these.
So
things.
It tells me my current KP, which is 2, in the what it's going to be in 4 hours is 2.67, and what I need is a 5.67, and so it was about 5.67. So it wasn't like it was anything super crazy special. It was just that, that it happened to be that, like, that's just like telling you that there is activity and there's a chance that you're going to see something. So mine was, and so you got to go out and spend your time out there and see what you can see. So, all right, let's get on with this episode. Apologies in advance. I don't have time to say hello to everybody because I was too busy self-promoting my own stuff. But I wanted to say we're going to quickly do the episode. Pamela's got a book out, so we're not going to be able to stick around for any questions. So I apologize in advance. Now, what we could do is I could just stay. You could leave, and I could just stay and tackle some people's questions if they're within my pay grade. But if not, we'll just shut down the stream. So.
And if any of you are local to the St. Louis area, I will be speaking at Archon all weekend, which is what I'm booking out to do.
Okay.
So yeah, come see me. Come see me in St. Louis if you're in St. Louis.
Right on.
But it's in Collinsville, so there's no protesters.
Okay. Sounds good. All right, let's go. I'm going to start recording.
I pressed record. Hi, Chad.
Hello, Chad. Here we go. Astronomy Cast, episode 459, Arecibo. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how's it going?
It's going well. How's it going with you, Fraser?
It's going great. I had what had to be my greatest aurora experience of my life. I posted my video to the Twitters and the Instagrams. You say I should send it to APOD. I'll send it to APOD.
Yes.
We'll see if they take it. But unbelievable. My phone bleeped at me, told me there was a big geomagnetic storm overhead. I went out to this cool beach that we have that has a nice north view and saw the most insane aurora activity I have ever seen. It was ribbons. It was different colors. It was purples and yellows and greens. I really, really, I can't. I'm at a loss for words. Anyway, so check my Twitter feed. You should see the video. But if you have never seen this, get like a phone or get a service. I know you use Twitter, and let yourself know that this is happening, and then go out and see if you can see an aurora.
It really is worth it. I've only seen aurora like you saw last night once in my life, and it was the kind of thing where we all just sort of stood there with our jaws open, and we hadn't been expecting it. We just had a campfire up in the mountains in New Hampshire, and lo and behold, all behind the White Mountains, it's one of these things you'll never forget once you see it.
Yeah, that's the real deal. Now, before we move on to the show, do you want to mention CosmoQuest's new service that just came out?
I might want to.
Do it.
So I want all of you, and I can see in the stats if you do this or not. I want all of you, when you listen to this podcast, to go to cosmoquest.org/image detective and help us explore our own planet. We're currently at a time when every time you turn on the TV, it's like we're seeing another, here's our planet wrecked kind of photo. But the thing is, when you look at Earth from space, it looks glorious and awesome and beautiful. And we have an entire citizen science project of photos taken by astronauts who do not label their photos. And if we want to be able to use these images for science to see when do you see the flowers blooming? You can actually see California bloom from the International Space Station. When are the rivers flooding? When do we see the first rains wetting down the farmers' fields and that first corn bloom? When do we see our Earth change? You can see all of this in Image Detective, and we need your help marking what is in every photo and figuring out what the heck the astronauts were looking at. So far, I found Gibraltar. I found a shopping mall in Saudi Arabia. I've found a bunch of weird, cool stuff. So go online, cosmoquest.org/image detective. And like I said, I can see in the stats if you do this or not. Do not make me be a sad person. Please make my stats blow up. Thank you.
Okay, Okay, the iconic Arecibo Radio Observatory has been a mainstay in science and science fiction. This Puerto Rico-based radio telescope was already in an uncertain level of funding, but now with the damage from Hurricane Maria, it might be shut down forever. So, like 2 weeks ago, if we're going to do an episode on the Arecibo, we would have talked about how it was financially in danger.
Yeah.
And now, and I'll show some pictures to the folks watching this live, but wow, it could have been a lot worse, but boy, it really took a big hit. So let's talk about, which one do you want to talk about Arecibo right now and just what happened, or do you want to kind of go back through the history first? Let's talk about what happened.
So for the first time since before the Great Depression, a massive hurricane, by which I mean it was at one point a Category 5, hit Puerto Rico with wind speeds of over 150 miles per hour. And the eye wall pretty much went across the center of the island, with the edge of that eye wall going straight over Arecibo Observatory. The island was completely devastated. There is no other way to put it. The entire power grid was knocked down. Fresh water system was mostly destroyed. The roads are such a mess that they're basically not able to get into people except with helicopters. Now, the thing about the observatory is it's high up. It's well above sea level. It's well above worrying about a local dam they think might fall down. It's well above the flood stage for that. And from its safe place that has generators, that has food reserves, that has a helipad, they are in a position to work on helping get the entirety of the island back online. So they're actually where FEMA is currently headquartered. But while they're there helping to heal the whole island, it's unclear what their own future might bring.
Yeah, and so let's talk about like what actual damage Arecibo suffered.
So the city was pretty much destroyed. The city, there's like a hospital in the process of falling into the ocean, which is not where hospitals belong. But the observatory itself, it was mostly unscathed. There was one very large radio line receiver that hangs down from that iconic centerpiece that is out over the basically crater of a telescope. And this 9-story long feed line fell. It took out several, and I mean like order of 10 panels in this order of 10,000 panel radio dish. So luckily the one that fell, the one that was damaged, that 430 line, it isn't used for a whole lot of the science. So most of the work the dish does, it can continue to do without that particular line feed. But not having power, you can only run on diesel for so long, and you can't very readily use that dish as a radar, which takes a lot of power when you were relying on generators for everything.
So right now, the Arecibo is completely offline. It is not usable for any science, and really until they get the instruments restored and the parts from the instrument cluster that fell down and broke, as well as the dish, as well as getting, they've got generators, but I don't think they have enough power to actually run the
Right.
instruments and stuff. So really there's a ton of work that needs to be done to bring this. And Arecibo was lucky compared to a lot of the places on Puerto Rico that were hit so much worse. Remember, you can even see Puerto Rico from space, and it is dark. It is, there is no power except for a few little corners of the of the island. So it's a bad situation. Arecibo is literally like now the worst of people, or the least of people's concerns compared to the human crisis that's going on this island right now.
And as we talk about the history, the skills, the amazing scientific impact that this observatory has had over way longer than you and I have been alive, I think that in a certain way, the noblest thing it has done is provide that ground zero for FEMA, where NSF has basically said, here, FEMA, take our facility. Here is our helipad. Here is our capabilities. We have a cafeteria. We have dorms, and now it's a place where hopefully the island can start rebuilding.
Well, so now let's go back and talk about Arecibo and sort of the history of the observatory. So how long has it been around for?
Uh, this is amazing. It was constructed in the 1960s. This thing predates the two of us. It was really built as the first of the mega observatories, and up until last year, it remained the largest of the mega observatories, and it took China to defeat it.
Right, the FAST telescope.
Yeah. So the origins of it go back to the 1950s when folks were trying to figure out a lot of radar technology. So this thing is based out of radar versus receiver technology. It was actually put together to be able to like figure out warheads, figure out spacecraft, figure out all of these little metal objects flying through the atmosphere and above the atmosphere. It did not originally get its start as something for studying like distant neutron stars. That's just kind of what it evolved to do. So it was completed in November of 1963. It was designed and run out of Cornell University for most of its history. And yeah, it started out looking at small metal objects, went on to study the ionosphere. And then the more we learned about radio potential, the more it got used to do, well, stuff with cosmological implications.
So let's talk about sort of the scale of the thing. So it is this gigantic radio dish, but it's built in this sort of really interesting natural formation, right?
Right. So I didn't use the word crater offhandedly. It's essentially in a depression in the mountains that looks like a volcanic crater. It's not a volcanic crater. It just looks like one. And where it's carved into this mostly already existing depression in the hills, it's 38,000 aluminum panels, each of which are several feet across. The entire thing adds up to 480,000 square meters. And it's suspended, all of these little aluminum panels are suspended on basically a hammock of big cables. And so build yourself a spherical hammock out of cables, plant shade-loving plants underneath it, and cover it all in an aluminum mesh. And because they're working at these longer frequencies, or higher frequencies, longer wavelengths, they're able to have this reflecting surface that reflects radio waves while also growing moss.
Right. Now, this is not a parabolic shape mirror like, like a typical telescope dish, and even like the way a lot of radio dishes. This is a spherical reflector, right? And so how does this work differently than what maybe people are expecting?
Well, with a spherical reflector, there's normal aberrations that you worry about in optical astronomy, because what they're looking at is a beam, and within the beam, do I see radio signal or do I not see radio signal? They're less worried about the distortion that you get from a spherical mirror. And what they're able to take advantage of with the spherical surface that you can't take advantage of with a parabolic surface is by moving around their focus point, they can essentially change what part of that sphere they're using to look at the sky. So instead of trying to tilt, bank, move a 480,000 square meter dish, what they're moving is that little pointy bit at the top that's on a bunch of cables. And by moving that around and changing what part of the reflected light gets captured by the feeds, they're able to track things for a moderate amount of time as they scroll through zenith, essentially.
So you can actually move your detector, this detector array that's on these cables,
Yeah.
as the Earth is turning, and be able to keep it fixated on some target. Or theoretically, if you've got an asteroid that's moving on some angle, you can move it and be able to target. And there is no other way that you could target a dish this big.
Right.
It's just not possible, right? It's just too
Exactly.
big, right?
Yes.
The scale of this thing compared to any other radio dish that's out there is just...
Except the one in China.
Except for the one in China, which uses the same technique, right? Yeah.
Yeah.
So what are some of the great discoveries that Arecibo has made us do, has helped us out with?
So it has been doing amazing things pretty much since day zero. So in April of 1964, it was used to figure out that Mercury, yet again, isn't doing what we expect it to be doing. It's like every time we're able to look at Mercury in higher detail, one of those things that we had always thought was true turns out to be wrong. With Mercury, what they figured out was they had thought that the planet was tidally locked to Saturn, and it's not. So they were able to figure out that it didn't have an 88-day period, but instead had a 59-day period for its rotation day to night. So that was kind of cool. In 68, it was able to figure out the speed at which the Crab pulsar is doing its pulsar thing, which is 33 milliseconds. One of the things that I think is particularly cool in light of the situation with Maria is it was used to find the binary pulsar, and I have to read its license plate number, PSR B1913 plus 16. This was looked at in 1974 when we both were finally alive, by Holson Taylor, and this was the first binary pulsar that was observed and allowed us insights on gravity and special relativity that had never been seen before. And the two of them actually went on to get their Nobel Prize for this. So this was work that was done. And Joe Taylor is about as nice a guy as you're going to get. Some of these Nobel laureates, you meet them in person and they're just like dorks with big toys that are having amazing results with their science. And Joe Taylor, he actually is a ham radio operator, and he was one of the first ones to get us information from the folks at Arecibo Observatory who also had a ham radio. So here's someone who did cutting edge work with a giant radio dish, figured out binary pulsars and aspects of relativity, and then helped us find out that at least some of our team down there was safe thanks to shortwave radio.
Right. I think, we talked about this a bit in the Weekly Space Hangout this week. Subtle plug for the Weekly Space Hangout. But, and one of the things that's really interesting about Arecibo is that, as you mentioned, it has this radar capability. And we did a whole episode of Astronomy Cast about radar astronomy, which is different from radio astronomy. But can you give people sort of a bit of a refresher on what Arecibo can do that makes it very special from pretty much any other large radio telescope out there?
So it has the capability to both send and receive. The first observatory I ever worked at, Haystack Observatory in Massachusetts, is another one of the ones that do this. Pretty much if something is partially funded by the military, it probably has radar capabilities. And radar is when you send out a pulse of radio light, and you measure the return time distribution and the packets of light, and you send this as a burst that goes out. The packets that get back to you first came off of something that's nearby. The packets that get to you second get to you off of something a little bit further away. And you can actually map out the distance to a bunch of different things by doing a sweep of your radio transmission and listening to the returns coming back off of that sweep. With Arecibo, they have the ability to use radar to actively trace features on a surface to accurately measure the distance to objects. This was how we accurately finally figured out how big our solar system is with radar astronomy. So it gets used with Mercury to look for features on Mercury and measure how long it takes for those features to come back.
Yeah. But even fairly recently, right? Like it has been analyzing asteroids that are doing nearby flybys of the Earth and being able to actually see features on the surface of these asteroids. It helped map asteroid Bennu, which of course now there's a mission that's on its way there. It's found moons around asteroids. Like, there are other radio telescopes, and there's especially the Square Kilometer Array, and there's a lot of really amazing observatories that are in development, but there just aren't a lot out there that have this level of radar capability in addition to its radio observatory capabilities.
And this, it's not just asteroids anymore, it's also comets. Back in February, Arecibo was able to observe comet 45P, Honda Mercos Pajuskova. We're going to go with Comet 45P, which is what they say at the top of the press release. And with the observations they made, they were able to peer through the coma of the comet and start to resolve, well, the sucker's rotating at 7.6 hours. They were able to figure out the size more accurately as being 1.3 kilometers or 0.8 miles across. And so you can do things with radar that you just can't do any other way because, well, in this case, the coma, that bright reflective cloud of volatiles around the nucleus of the comet, you just can't easily look through it. And so here Arecibo is out there actively imaging asteroids that get near the Earth, actively imaging comets that get near the Earth using radio light, which it sends out instead of using reflected sunlight like all the optical telescopes do.
Yeah, and so we're going to miss that capability. Let's talk about some of the actions that Arecibo has been used to attempt to communicate with aliens.
I like the way you're like, what word do I use for this? So back in 1974 was the first example of Arecibo essentially sending out a message, and it was essentially the silliest little 8-bit monocolor graphic ever. I don't even know how an alien would make sense of this thing. It doesn't even fully make sense to me. But anyways, Arecibo in 1974 beamed out a 1,679-bit pattern to make a 23 by 73 pixel bitmap image that any life in the globular cluster Messier 13, which we now know doesn't have any planets, had there been planets with life, or should there be life without planets in M13, they will at some point far, far, far in the future, like 25,000 years from now, they'll be able to see this 23 by 73 pixel bitmap. And maybe, hey, there's something between here and there that will receive it in the interim.
Well, how do you know that there's no planets in Messier 13? It's 25,000 light years away. It has tens of thousands of stars in the cluster, each of which could have planets.
They have, and by they I mean a number of different research teams have uh, looked for flickering of the stars consistent with transiting stars at such a level that were there planets, it's believed they probably would have found them by now, at least one or two. Um, they did an in-depth study, I believe, of M15 using the Hubble Space Telescope. Um, and these objects have such a low metallicity that this is actually consistent with our understanding of you have to have heavy elements in order to have planets to form out of the heavy elements.
Right. I still hold out hope. 25,000 light years away, too far away, many stars in there. Who knows? Who knows?
Okay.
Yeah.
Okay.
And
you can do
know,
this.
if we're talking about maybe we could be finding life on Pluto in the radioactively heated subsurface areas, you don't know.
You just need a surface.
Yeah, exactly. Ice. You need ice, and you need radioactive materials. Now, of course, the problem is, and so if we didn't have what happened just with Hurricane Maria just in the last few weeks, Arecibo was already in a bit of a funding crisis. Can we talk a bit about that and sort of where we got to?
Yeah. So, Cornell had been operating Arecibo for decades. I remember when I was an undergraduate, if you wanted to be a summer student at Arecibo, you actually were a summer student at Cornell who then flew to Arecibo. And the issue became that the National Science Foundation, which had been operating Arecibo via Cornell as one of their major facilities, wanted to change the funding structure. So in 2011, the National Science Foundation basically told Cornell, we're taking away your toys. They said it slightly differently in a slightly nicer way, but that was the gist of it. We're taking away your toys. We're going to transfer operations to a completely new facility. We're going to be bringing on new management partners, and we're going to ask everyone to try and find ways to fund this that don't include the National Science Foundation any more than is absolutely needed. So back in 2011, the Stanford Research Institute, SRI International, went on as the lead organizer. Along with that, it's being managed by USRA, which is a standard organizing body. They run a lot of the major orbiting observatory contracts. They run a lot of contracts. USRA is the university's plural space research association, so it's an association that runs these kinds of facilities, as well as the university. I think this translates to the Metropolitan University of Puerto Rico. The Spanish pronunciation is Universidad Metropolitana de Puerto Rico. Again, I speak Russian. I'm sorry. And with this new funding source, this new way of looking at it, it has since then been consistently threatened to be shut down. We have heard numerous times when, while trying to figure out the budget for the next year, it's been, and we close Arecibo. And everyone's like, no. And then NSF comes out with Dear Colleague letters, and they've done this at least twice now, with the Dear Colleague letters saying, we are looking for someone to run this who will cost less. Again, they don't phrase it exactly that way, but that's what it boils down to. They're looking for someone to run the facility in a competitive manner that will allow the National Science Foundation to spend less money for their science return.
Right. And I, when you think about like all the NASA projects that are, they say they're going to shut down the Voyagers, they say they're going to shut down the Pioneers, and like someone goes, oh, well, wait a second, we'll cover it. They say they're going to shut down the Mars exploration rovers, and they find the money. You can imagine them finding the money year after year after year moving forward with Arecibo. But now it's not just find the money to keep the thing operating and, put off the maintenance of the cleaning the moss off the detector, until next year. It's going to take an investment to get it back online before you can even move to that maintenance phase. So did Maria hit it with a death blow? Is it done?
We don't know yet. And this comes down in part to being a ethical question. And it's a complex, gray ethical question, as so many of them are, because on one hand, Puerto Rico employs over 100 people. It provides this place with high-tech, high skills jobs. The visitor center does education and public outreach. This is a facility that has a positive and wanted impact on its local economy, on the local education system. And it's kind of this shining star. It's also a historic site. And at the same time, how do you justify the funds that are necessary to rebuild a facility that, yeah, it does good work. Yes, it does unique work. No, there isn't anywhere else out there that can do exactly the kind of imaging that it does. Manchester, up in the UK, does a fair amount of radar imaging as well. But Arecibo is the big boy out there doing it. And the women like Sandy Springman that are out there operating it and getting these amazing scientific returns. Yeah, that's awesome. But there's people without water. Mm-hmm. There's so many other needs. How do you justify spending on something that does after school help and educational programs when there is no school?
Yeah.
And I don't know the answer. And I'm not sure anyone will know the answer until the roads are clear.
Yeah.
And the roads still aren't clear.
So we'll keep you posted.
Yeah.
Thanks, Pamela.
Thank you. And now we save.
Export.
Yep. Sorry for the downer, folks.
Oh, you can go if you want to.
I have to save.
Well, you can do that offline if you need to.
Yeah, I'm going to dash as soon as I get this stuff saved. Mm-hmm. Okay, everyone. So please, 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 for the love of God, please go to, say it with me, cosmoquest.org/image detective and explore our planet Earth. I will be looking at the stats tonight, and I had better see as many people logged in after Astronomy Cast as watched this episode on top of the trend line that was already there. I expect to see a statistical deviation in the trend line.
You hear that, everybody? You're on notice. All right, I'm uploading my episode.
What episode number was this again?
459.
Thanks. Okay, and I am off and running, and this has been fabulous as always. And yes, all of you asking, I can be on the Weekly Space Hangout. So
yeah, she's been on the Weekly Space Hangout many times in the past.
They want me to come on, I think, and talk about my project as a guest, which I have not done before.
Good idea. Okay, yeah.
Okay, I'm running.
All right, see you
Bye-bye.
later. All right, I'll jump in and answer anybody's questions if you've got some. Otherwise, we'll wrap this up. If anyone wants to hear me redo my rant. All right, see if there's any questions here. Arensjo says it would be an amazing skate park. It actually was. The Arecibo was actually in Battlefield 4 as one of the set pieces. You can actually blow it up, and it really felt bad to me that you could destroy this really cool radio observatory. It wasn't the exact one, but you could. Yeah, and Guido's exactly right. Rebuild Puerto Rico first, then the Arecibo. Maybe it'll take time, but it isn't going away. Yeah, the damage wasn't too bad, so it's not like you're gonna need to, like completely rebuild the observatory. It's just you got to decide, priority on getting human beings into a safer place before building, fixing the radio telescope. All right, well, I'm going to wrap things up. As Pamela says, I guess I need to... James Aberson, yes, I did see Elon Musk's talk, and I'm actually going to work on an episode for the Guide to Space right now about it. And I actually sort of half ranted about it at the beginning of this episode, the gist being, on the one hand, I think... He really simplified everything, right? There's just the BFR. There's just this great big monster rocket that's going to be used for launching satellites, collecting satellites, going to the moon, going to Mars, traveling on to Earth. It's a pretty simple, elegant system. And if their plans are right, this thing is going to be able to even do suborbital launches here on Earth. So it makes a lot of sense. And if they can bring those costs down, there's really nothing that can compete against this fully reusable, even solar-powered rocket, right? They're going to be able to run big solar systems that will pull the oxygen and build the methane that will actually let this thing be able to take off. And so it's a pretty clever, elegant solution. I'm not super convinced that the way you help fund this is with suborbital launches. I don't think there's any business model that's going to be able to sustain people having to spend $100,000 or $50,000 on their ticket to knock 5 hours off their flight time to go from Los Angeles to Shanghai. But apart from that, it still seems like it's pretty cool. I mean, I think the way you fund this is you build a internet system that's going to provide high-speed internet phone service to everyone on planet Earth. I mean, that is crazy, right? That would destroy the telecommunications networks, and they would have a very difficult time catching up with them at that point. That's how you fund it. So, but I do, if they can build this BFR and they can make it as inexpensive as they say, I think that's going to be amazing. I think that's a really great way to go about it. If you watch the episode, they talk about the timeline, and they're still planning to send the first rockets in 2022, which is crazy to me. And I would be really amazed if they actually do send the first two BFRs to land on Mars by 2022, which is only 5 years from now. And then to send the first humans 2 years later in 2024. Again, that just sounds quite amazing. I would have expected them to push these timelines back, but if they want to stick to this aggressive timeline, then we'll look forward to them pushing the timelines back in a couple of years, which I think, we always have to go back and say, they land, like, we can be skeptical about what SpaceX does, and yet you can look at 16 successful landings in a row of these rockets. And now the next step is they're going to be landing these rockets right within their launch gantry. That's amazing. So it's like on the one hand, people are always so skeptical, and on the other hand, they do this. So I'm pretty excited, and they're going to encounter the problems. They're going to be like, oh, turns out you need that this carbon fiber fuel system isn't going to work, but they're going to figure out what's missing to get to the next level. So I'm pretty amazed and to see what happens. So I will be watching this with bated breath like the rest of you. So I guess I should run. I do have an episode to work on. I better get writing to put these ideas down into video form, but and that should come out in a little while. But we'll see what happens. I would love to hear what you guys think. All right. We'll see you all. Next up is going to be the Weekly Space Hangout next Wednesday, and then, of course, another Astronomy Cast on Friday. Thanks, everyone, for watching, and we'll see you all next week.